Buona nit. Buenas noches. Good evening. Welcome to the Red Eye. Nice and quiet, nice and late, nice and peaceful. Love it. Right, why are we here? I just wanted to get this one done before I went to bed. I got caught up with other stuff, so this is about the absolute light radiating from the sun, and we know it is absolute because there is no delay between the sun and the shadow, right? We know there's no delay because we can see the sun's corona around the moon. It is directly behind the moon when the shadow is being cast, okay? If there were photons, the second that these photons left the sun for the particular sweet spot that we're talking about, that sweet spot would be facing 2.08 degrees that way. Photons leave, 8 minutes and 20 seconds travel time. In that 8 minutes and 20 seconds, planet Earth is turning anti-clockwise on its axis. 8 minutes and 20, bang, the shadow. But the sun that is behind the moon launched the photons 8 minutes and 20 seconds ago. Now, it isn't logical to think that the sun would be in the same position as the photons that it fired 8 minutes and 20 seconds ago. It cannot be there. It's a paradox. Solar eclipse cannot work with finite light because it would never be behind the shadow. And it is directly behind the shadow. There are no outs. It's airtight. The only way out of it is with an absurdity, right? There is no absurdity that can convincingly turn this into finite light and make it work. It just cannot happen, right? It cannot happen. It's one of those things, and it's more than obvious, and you can see it play out in every solar eclipse that comes your way, right? There is no delay. Now, Galileo Galilei. It's just one after another. If Galileo was the scientist they say he was, he would never have needed to run through the motions of grabbing an assistant. Come here, Domel. You go up that hilltop, I'll go up this one. So 2 kilometers apart in the 1600s. What happens next? He's up one hill and 2 kilometers away, his assistant, he wouldn't even be able to see him, would he? Going to tell me now that they're going to be using telescopes, right? And open your lantern and in the dark, not able to communicate with the... What are they talking about? This is the insult to people's intelligence, right? But nobody's picking it up. Everybody's just accepting the stories. Why? I don't get it. I don't. If Galileo were that naive, right, he wouldn't have come up with all of the other stuff that he did, right? He wouldn't. Even people nowadays would not even bother. They'd laugh. You want me to go up that hilltop with a lantern and you're going to try and give me a break? It's ridiculous. That didn't happen. For the simple fact that he wouldn't have been that stupid. But the main reason is because it's absolute light. Well, saying that, he didn't accomplish it, did it? So the absolute light is irrelevant, totally irrelevant. He just would not have been that stupid, okay? Insult number one to people's intelligence. Then we move on to Roemer. We have the sun. We have 4 different points of our orbit around the sun. Roemer in the 1676. That roughly be Mars. Then we have Jupiter, and this is Io, right? Comes anti-clockwise, same as us, going round. That would be Callisto, Europa, and Ganymede. 4 moons orbiting Jupiter. Io has a diameter of 3,643 k's. Our moon is 3,476, so Io is a little bit bigger than our moon. Jupiter has a diameter of 139,822 kilometers. That is over 1/10 of the size of the diameter of the sun. Over a tenth, just over a tenth, right? Us, 12,742. If Jupiter is divided by Io, number 38. Io is only 1/38 the size, diameter of Jupiter. 4 other moons. 1676 with a telescope, that's questionable, because in the 1960s here, they were still thinking that vegetation was on Mars. They thought there was ice. So how good could the telescopes have been in 1676 if they were still thinking that there was vegetation on Mars in 1961? Don't forget, folks, we're talking 1676. This is when Roemer allegedly did what he did. We had, what was it? 359 years. 2025. It's a long time ago. Electricity in Europe, 1880, give or take a year. Electricity. (1676). Zero of anything. No time, no accurate timekeeping devices. 1676. These numbers, why are people not understanding what is being said here? Our moon is 3.6 times, we're 3.6 times bigger in diameter than our moon. Jupiter, 139,000 k's its diameter, right? Io is 1/38 of the diameter of Jupiter. 1/38, orbiting 3 other planets. Now, here's number 1. This is the first position. That, it doesn't matter which one, right? Might as well start at the closest. It is said Roemer took a reading from this position and he saw Io come out from behind Jupiter. Boom, right? Our closest to Jupiter in our orbit around the sun. It takes Jupiter roughly 12 years. So we orbit once from there. Jupiter has gone a 12th, like a clock, 12 hours. We do 1 whole revolution, 12 hours. Jupiter does 1 hour. Get it very close to that, right? 12 to 1. He did what? So what did he do? Got his telescope out, had a look, reckons that he saw Io, and what did he do? At night, no electricity, he would have maybe had a candle, but what would he write down? What time would he put? 1676. What time would he have put with what? An hourglass? Don't forget, The next reading was 3 months later. So now we've moved. 3 months later, he takes another shot. So he says, right, I'm going to check again and see what happens, see what's happening with Io. Why would he? I mean, look. So he takes another look, and somehow he works out that there is a little light delay. As we've moved a little bit further away, as he's been looking, he's probably been thinking, where's Io gone? Oh, maybe everything is wrong. And then out it popped. Oh, there it is. It took a little bit longer, apparently, to be visible from behind Jupiter. And then he took another reading, another 3 months later, right? When we were our furthest from Jupiter, but still just about see Io, likely story. He took another shot. And when he was at this position, number 3 position, because he was it's furthest away through Jupiter, as he was looking with a telescope. See, that's another thing. You're using a telescope. If somebody on Pluto was at the same angle and was using a telescope, they would all see the same thing. They're using a telescope. Oh, it's just insane. It really is. It's like a B grade movie. It really is. Oh, who writes these fucking scripts? It's fun though. What else would you be doing, eh? So, from the number 3, it took an extra, what was it? Something like 10 minutes. Well, it's 150 million kilometers from us to the sun. 150 million. And so when it was that side, it's another 150 million. So the total distance between that Earth and that Earth is basically 300 million Ks. So it takes 8 minutes and 20, doesn't it, to get to us? So you're looking at 60 minutes 40, give or take. It's something like that. Common sense. Twice the time for the photons to do their magic. Okay, the invisible massless photons. And apparently, they show you this card that they reckon it was his. Well, it obviously wasn't his, was it? It obviously wasn't, because look, this is the thing, right? This is the thing. It's absolute light. So none of these people did this. This is how easy these things are to work out when you're objective and you use logic and you're not biased. It's a very, very fast case of that didn't happen, that didn't happen, that didn't happen. And we know this because there is no delay. Here's me still finding reasons as why Roemer didn't, or Galileo didn't, or Wheatstone or Bradley, right? But the main reason is because, look, so what this is how the lies work, the deceit. If you can be objective, you can understand that is absolute light, which it is. Why would they say all those people tried to work it out and they just so happened to all get to within, I don't know, 5% of each other, and they all ended up on 299,792,458 meters per second? It's ridiculous. It's just ridiculous. So Roemer didn't happen, right? It just did not happen for quite a few reasons. The first one, it's absolute light. So why would he have? So here we are. We've got our solar eclipse. I forgot to say, Daisy the cow. There's the moon. Daisy the cow. There's the moon. And look, it doesn't matter. I mentioned Daisy the cow. We're being told that Roemer saw light delay as Io came out, boop, there from behind Jupiter. But during our solar eclipse, there is no light delay. So why would Roemer see a light delay? It's absolute light. It doesn't matter how far away from the sun an object is. If there is a shadow involved, the sun will be directly behind anything that is casting a shadow, and the shadow will be in the perfect line. This cannot be argued with. It's right there for everyone to see. I've been doing it nearly every day for 2 weeks now. A solar eclipse cannot happen with finite light. This is an irrefutable 100% fact. It doesn't matter. I was going to say what the teachers say. They will never, ever, ever be able to come up with a logical reason for why the sun is directly behind the moon during a solar eclipse. There is only one reason, and it's very, very obvious, because the sun is directly behind the moon. The shadow, the sweet spot, can only be lined up with absolute light. There is no doubt. It should be obvious, right? It really should be obvious. And then when you start to see all of this stuff, right, you have to say to yourself, well, hang on a minute. Things are so obvious. And don't forget, folks, just like the moon, Apollo 10 didn't go up there and take those photographs for Neil and Buzz and Michael. 2 months later, it didn't happen. It did not happen. If one didn't happen, the second one didn't happen. That's how these things work. They all piggyback each other. These speed of light things are. And it was thanks to such and such who did first the very pillar stones of the calculations for the speed of light. But he didn't. He didn't. So, and he didn't for plenty of reasons. He didn't because it's an absurdity. 1600s, what on earth is anybody doing in the 1600s looking up of all the things he could have been doing on planet Earth? He was looking up at Io. But how long does it take? Oh, what is it? I can't remember. 40 hours? Alexa, how long does it take for Io to orbit Jupiter?
From LATimes.com. It takes them about 2 Earth years to orbit Jupiter.
Oh, for crying out loud. Alexa, how long does it take the moon Io to orbit Jupiter?
From Wikipedia.org. It takes Io about 42.5 hours, 1.77 days,
Alexa,
to complete one orbit around Jupiter, fast enough for its motion to be observed over a single night of observation.
42 hours. What did she say? Fast enough that the whole thing can be observed over a night? No, I'll pretend I didn't hear that. I must have heard wrong. So, there you have it. Io, 42 hours. It's 1/38th the diameter of Jupiter, and it's orbiting Jupiter at an average distance of 422 k's. Hour 384. Just little comparisons. And you think, in 1676, 359 years ago, 100 years, 200 years before electricity, that he somehow took a first reading, somehow found a way to properly record the time. I can't do it. I can't do it. I really can't. It's so stupid. It's so stupid. And then, look, let's go through the motion. And then he would have taken another reading. We can call it number 4, right? And he would have used his super duper hand shippery telescope that had just fallen out of the truck, out of the factory. And when he was at this one, he would have seen Io a little bit sooner. Again, it is said, because he was getting closer again. But we know that there is no light delay. It's absolute light. So when Roemer was looking at Jupiter and Io, anybody anywhere with a powerful enough telescope would have been seeing the exact same time Io came up from behind Jupiter. Because with absolute light, everybody is seeing the same thing at the same time. There's no wormhole going to pop up and bite your ass, and there's no hocus pocus anywhere. There's no freaking spookiness at a distance. It's just they do fairly often, you'll hear them say, theoretical and hypothetical. People, you need to pay more attention. Well, oh, sorry about that. Excuse me. I am tired. I think I'm going to call that. There's nothing else. You cannot argue against absolute light, guys. It's very obvious. Roemer, Galileo. Hey, Topolino, come here. You go up that hill, I go up that hill. But Galileo, how are you going to call me in the dark 2 kilometers away? Topolino, good call. Let's go have an espresso. All right.